Hello, my name is Patrick, and this is my presentation on my critical inquiry project, the impact of short cycle formative assessment. All right, in today's presentation, I'll cover the research question, my methodology, my results, discussion, and future recommendations. Okay, my research question. What impact does the consistent application of short cycle formative assessment have on improving learning outcomes for students? So focus on implementing short cycle formative assessment and measuring these results. Before I continue, just to clarify some of the points in that inquiry, a definition of short cycle formative assessment. This is feedback which is provided immediately to a student. It can't be feedback provided after marking assignments over the weekend. It is provided in the class so that students have constant feedback on how they're progressing. In practice, the way that looked for me is I teach a grade 8 maths class in Huonville, Tasmania. It meant that I was providing students with answers to all of their work so that students could self-mark or I could be marking with them. That way they were seeing constantly where they were going, and if there were errors occurring, I'd be able to intervene there. So standard practice was if a student got 2 out of 10 questions wrong, then I would come and intervene and work out what was occurring. One question could have just been natural error. I will admit that this is a lot easier to do in maths than a subject like English because maths tends to have right and wrong outcomes. All right, the methodology for this study. So the way I did my testing, I based it on Hattie's 2009 Visible Learning, the synthesis of 800 meta-analyses. So this is based on student achievement. He uses the term effect size, like the effect on student learning. His work is highly comprehensive, and I've used it often to guide my own teaching practices. So I wanted to model my research project on the methods that he uses. The main method being calculating effect size, and he does that using the equation which is up on the presentation, the diagnostic test score minus the summative test score, and then you divide that by the average standard deviation. So I use this to create my data sets. All right, an example of the raw data is shown on your right here. So the way I did the data, students would complete a diagnostic test at the start of the unit. That was always given out to them quite early on. The unit was then taught with lots of short cycle feedback, so ensuring students were checking their work as they were going, marking it, and then they completed the summative test. What you see on the right is the evidence of step 4. Students reflect on their growth between the two tests. So at the top, you can see they have their mark for the diagnostic test, 25%, and their mark for the summative test, 75%. So students were able to reflect on their own growth, but for this student, they've gone up by a large amount, but it also provided me with really clear indication of how they went and how they improved, and a bit of a reflection from them. So it doubled as a good learning tool for me and a good way for students to acknowledge their own growth. All right, the outcomes. So using the methodology outlined by Hattie, I was able to work out the effect size of the short cycle formative assessment. You can see that on the chart. So each blue line is a student's effect size between their diagnostic and summative test, divided by the standard deviation. The black line is 0.4. Now for Hattie, this is a really important number. 0.4 is the effect size of natural growth. So a student who doesn't even attend class will have a natural effect size of 0.4 just through natural growth over the course of a school year. So you want to be above 0.4. As you can see, the majority of students are above 0.4, including some really, really high results to the upper end there, over half being an effect size of 1, which is huge. So the key point is that short cycle formative assessment has had a positive impact on the large majority of students and it can be seen that growth has been shown beyond natural variation of that 0.4. Right, so a bit of a discussion and a link to what we're seeing in some of the literature. So the results align with theories by Hattie, Black, and just sort of known sort of anecdotal evidence that students will grow when you give them constant feedback. So short cycle feedback is effective for students and is able to help them correct the errors that are occurring as they're occurring. To facilitate this, I actually used a Pearson 8 textbook. This is because it has the answers in the back of the book, so students had a period of time at the end of a lesson to check their answers. This was a new practice for the school. No one at the school was using textbooks, so it was seen as quite an out there concept. But the short cycle feedback, the results are showing and aligning with the literature that this is an important way to teach students. Recommendations is that there needs to be further testing against a control class. There is no control to compare against, so how much of this growth was going to occur without the short cycle feedback. Ensure the diagnostic tests are challenging. If they're too easy or too hard, it skews the first part of the data set and can create odd results. And ensure that short cycle feedback can be implemented into the classroom with textbooks, so ensuring there's more textbooks. All right, and that's it. Thank you for watching my presentation.